In the previous videos, we discussed about functions and different operations on functions, correct? So now let's understand different types of functions. See the first one. Here, this type of a function is what we call as an identity function. So this is an identity function. Now why we call it as an identity? The reason is the function in this particular form is given by f of x is equal to x. F of x is equal to x. This is basically the function what we have. So for every value of y and x are equal here. In the sense, if you look at this, when x is 1, y is 1. When x is 2, y is 2. See this? Everywhere the value of x and y are one and the same. That's why this type of function is what we call as identity function. Okay, this is the first type of function. Now here, your range and domain, the domain is basically set of real numbers and range is also set of real numbers. Every number it can take. Fair enough? Now let's do the second function now. See, the second function is what we call as a constant function. So this is what we call as constant function. Now in a constant function, if you look at this, no matter what the value of x you have, see, take any value of x here, the y value is constant, isn't it? That's why this is what we call as a constant function. Now constant function can be of two types, in the sense the constant function can be because in the x-axis or in the y-axis. Okay, here we have a value that, see, in this case f of x is equal to 4 because y is equal to 4. So this is basically a function and what we call as a constant function. Fair enough? So this particular value or this type of a function is what we call as constant function. The range and domain, here the domain can be set of real numbers. Okay, so the domain is set of real numbers, but range is only one value. Only one value, because no matter what the value of x you take, y value is always the same, right? That's why the range is going to be that constant k, whereas the domain is the complete set of real numbers. Fair enough? Now let's do the next one. See, the next what we are doing is we look into the polynomial functions. Polynomial functions, you know what is a polynomial. I don't have to explain what it is. Now, whenever we write a polynomial function, can be either linear, quadratic, cubic, biquadratic. There are nth degree polynomial also. But for now, let's concentrate on two very important type of polynomial functions. That is a quadratic. See the one what you're seeing right now? This is a quadratic polynomial. Correct? So it's a quadratic function. Now, if you look at this, it's going to be a parabola. Isn't it? Last year you guys have learnt about this. So it's a parabola. In this case, the function is going to be f of x is equal to ax square plus bx plus c. Depending on the value of a, b and c, the curve is going to change. But then here the degree of the polynomial is 2. Again, here the domain and range. The domain is going to be set of real. The range is also going to be set of real numbers. Fair enough? So this is basically the graph of a polynomial, one of the types of polynomial function. Now we'll look into the other type of a polynomial function. In the sense, we'll try to understand how a cubic polynomial is going to work, or a cubic function. This is a quadratic function. The next one we are going to look at is a cubic function. See, this particular type of function is what we call as a cubic function, or a cubic polynomial also you can call it. See, what exactly happens in a cubic polynomial or in a cubic function? You have a particular curve, right? So we can write this as f of x is equal to x cube, or in general you can write it as ax cube plus bx square plus cx plus d. Okay, so this is the general cubic polynomial function. Now, for the range and domain is set of all real numbers. Range is also set of all real numbers. Fair enough? Because it can take any value. Take 0, -1, 2 by 3, take anything. Set of all real numbers. Fair enough? Now, let's move on to the next one. The next type of function, so these are what we call as inverse functions. Or this particular function is an inverse function. Okay, so here the function is going to be f of x is equal to 1 by x. This is an inverse function. Fair enough? Now, whenever we talk about f of x is equal to 1 by x, we have to be very careful about this particular function. Okay, the reason is whenever you take f of x is equal to 1 by x, if you look at the graph, here it's not going to touch the x-axis or it's not going to touch the y-axis. Same thing along with the negative side also. That means these type of lines or these type of curves are what we call as asymptote. So asymptotes are those lines, as you go on further increasing the values, they become closer and closer and closer to one another, but they will not meet. So this particular line, that is x-axis and y-axis, both the axes are asymptotes to this function 1 by x. Fair enough? Now, the next part is when you have f of x is equal to 1 by x, here calculating the range and domain is very important. But along with that, whenever you're defining this function, we always have to write x is not equal to 0. X cannot be 0 here, obviously, right? So now comes the domain and the range. See, when it comes to domain, first thing, it cannot be 0, obviously, correct? So set of all real numbers minus 0. Except for 0, it can take any negative value. So all negative values are possible, all positive values are possible except 0. Now coming to the range also. You can have all the values except 0. Because when x, see, if f of x becomes 0, then x should become infinite. It's not possible, correct? That's why here also set of all real numbers minus 0. Make sense? So this is going to be the inverse function. Okay, now let's look into the next type of function. This function is what we call as modulus function. Modulus function. So here for a modulus function, the function is going to be f of x is equal to mod of x. Modulus is always positive. That's why if you look at it, there is no negative y value. Correct? So everything is positive here. Now coming to the domain and range. So domain is set of all real numbers. Give any value. But when you talk about range is basically all, you can say all positive real numbers including 0. In the sense, it can take any positive value including 0, but there are no negative values. That's why it's r plus 0. This becomes the domain and range for a modulus function. Alright. Now let's look at one more function. This function is what we call as signum function. Signum function. Now for signum function, it's a very peculiar type of function because the value, the function is going to become f of x is equal to mod of x divided by x, where x is not equal to 0. Quite obvious. Okay, now if you look at this, suppose if x is a positive value, then everywhere it's 1. So that's what we are looking at here. for all positive values. Suppose if x becomes negative value, anything, any negative value, then this entire curve is going to come where you have negative. That means if you try to find the range, or if you try to write the function here, we write the function as f of x is equal to, so in this case, when you have 1 when x is greater than 0, any positive value, minus 1 when x is less than 0. Of course, x cannot be equal to 0, isn't it? That's why these are the two values. Fair enough? Now coming to the domain. Domain is set of all real numbers except 0. Except 0. Now coming to the range. See, range, it has only two values. Either the value has to be minus 1. So what we can do, minus 1 is included, right? But is 0 included? It's not included. Correct? Now you can write it in two ways. One is with the, if you remember the open and closed interval, that method. Or you can also write it this way. Minus 1, comma 1. Only two values. So this is the range and domain of the signum function. Now, in this video, you learned a lot of different types of functions. Please go back, go through the video one more time so that you understand what is the range, what is the domain, what is the function, and how does it look like. Okay, in the next video, we'll solve few problems based on functions.